Hello everyone. In this session of Meet the NEET, we'll be looking at in tricks in reductive ozonolysis of alkenes. Okay. So what is reductive ozonolysis? The substrate used here is alkene and the reagent used here is ozone followed by a reducing agent. Okay, zinc and water plays the role of a reducing agent. That is why this reaction is called as reductive ozonolysis. Okay, now if you are subjecting an alkene to ozone, what it does is ozone cleaves the double bond and it forms a ozonoid. Ozonoid is an intermediate. This intermediate is highly unstable. When you are subjecting it to a reducing agent like zinc and water, it immediately cleaves to give corresponding carbonyl compounds. So this can be, the products can be either aldehydes or ketones. We'll look at an example of ethene. Ethene, when subjected to reductive ozonolysis, gives 2 molecules of formaldehyde. Okay. I will tell you certain steps that can be used to identify the product. What are the steps? In reductive ozonolysis, what happens is the alkene bond is completely cleaved. The double bond is completely cleaved. So what you write is remove the double bond completely from the substrate. Okay, then you write a structure like that. Then what you have to do in step 2 is introduce a doubly bonded oxygen atom onto alkene carbons. The carbons that were previously part of the double bond. On that carbon, you have to introduce double bond O. I will show you an example. Now I have taken the substrate 2-butene. 2-butene. Okay. So this I am going to subject it to reductive ozonolysis. So what is the first step? I have to write the substrate in such a way that there is no double bond. So when I write it, I get 2 fragments. 2 fragments. Now next step is onto the alkene carbon, I have to introduce doubly bonded oxygen. That is what I have done. This was the alkene carbon. This is the alkene carbon. So onto it, I am introducing double bond O. Double bond O. So what is the product I am getting is 2 molecules of acetaldehyde. So when 2-butene is subjected to reductive ozonolysis, I am getting 2 molecules of acetaldehyde. We will see another example. So now I have taken a cyclic alkenes and I am subjected it to reductive ozonolysis. So as said previously, in the first step, I should remove the double bond. So I have removed the double bond completely. Now these are the alkene carbons. These are the alkene carbons. So in the step 2, what should I do? I should introduce double bonded O. So on the alkene carbon. So I'm introducing double bonded O on the alkene carbons. Okay. So this was kind of a cyclic structure. I am writing the same thing in linear fashion. So you have 6 carbon atoms. Again, there are 6 carbon atoms on this. And at either end, you have double bond O. So on either end, you have double bond. So this is the product. Okay. What is the utility of reductive ozonolysis? It is used to locate the position of double bond in the alkene. It is used to locate the position of double bond in the alkene. For example, I am subjecting an alkene to reductive ozonolysis. I don't know what the structure is, but I am getting 2 products. I know what the products are. They are 2 acetone molecules. Then how do I arrive at the alkene? So you have to follow the following steps. What is the first step? Write the carbonyl compounds in such a way that the carbonyl groups are nearby. So 2 acetone molecules I have written. I have written in such a way that the carbonyl groups are nearby. Okay. Next step, what you have to do is remove that oxygen. Remove the oxygen of the carbonyl and introduce the double bond. So I have removed that double bond O and introduced a double bond between the both carbons. So previously, what I have followed, the reverse steps I am following it to locate the double bond. Next, I will put you one more, I'll show you one more example. The example reads, reductive ozonolysis of alkene X gave a mixture of two isomers of formula C3H6O. C3H6O. Give the structures of the alkene. Okay. So we all know that on reductive ozonolysis, the products can be only aldehydes and ketones. Aldehydes and ketones alone can be the product if alkenes are subjected to ozonolysis. Okay. So I'm given the formula also. There are 3 carbon atoms. So you have to find ketones or aldehydes with 3 carbon atoms. What can they be? They can be CH3, CH2, C double bond OH. Okay. Or then the other isomer can be CH3, C double bond O, CH3. Okay. So only these 2 isomers are possible for carbonyl compounds. Now what you should do, I told you, you have to write both the molecules in such a way that the carbonyl groups are nearby. So I have written. Next step, what should I do? I should remove the carbonyl oxygens. So I'm going to remove the carbonyl oxygens. Okay. Then what should I do? I should introduce a double bond between them. I should introduce a double bond between them. That's it. So this is the product. So what is the product? CH3, CH2, CH, double bond C, CH3, CH3. So this is the product. So through ozonolysis, I am able to locate the position of the double bond. The position of the double bond is this. Okay. So moving on, I want you aspirants to try these problems by your own. Okay. First one is, I've given an alkene. I am subjected to ozonolysis, reductive ozonolysis. Okay. The twist here is I have 2 alkenes. Examples I have shown is only 1 alkene. So again, another example is benzene. Benzene has 3 alkenes and you are subjecting benzene to reductive ozonolysis. So how you should proceed? You have to remove the double bonds completely. And on the alkene carbons, you are going to introduce double bond O. Okay. And third one is an example used to locate the double bond in the alkene. See this, find the alkene if the product of reductive ozonolysis is this. They have given you the product, they are asking you to locate the reactant. So I hope the points I have told you will be helpful in solving these problems. Thank you.